In this video, we'll analyze which groups migrate most readily in the Baeyer-Villiger reaction. At the top left of the slide, you'll see the ketones substituted on one side with a phenyl group and on the other side with an R group, which could be methyl, Me, ethyl, Et, isopropyl, IPR, or tert-butyl, TBU. Trifluoromethyl peroxy acid is the oxidant. The first possible product resulted from the phenyl group migrating as the tetrahedral intermediate collapsed. The second possible product resulted from the R group migrating. In the table, the yield tells us which group migrated more readily. Take a minute to look at the data and see if you can explain which group migrates most readily. One of the main things that we notice with a methyl or primary migrating group like ethyl is that the products are almost exclusively a result of phenyl migration. Secondary and tertiary groups migrate more readily than phenyl. As the group migrates, a slight positive charge develops at the migrating carbon. So, the group that can best stabilize that positive charge in the transition state has the lowest activation energy and migrates most readily. Overall, tert-butyl migrates more readily than isopropyl, more easily than phenyl, and then followed by ethyl and methyl. Try to predict the outcome of the reaction on this slide. Ready? The reaction mixture is basic, so the carboxylic acid, pK of about 5, is deprotonated. This has essentially no effect on the main reaction. A hydroxide deprotonates the hydrogen peroxide. Because the reaction is under basic conditions, the carbonyl group is not protonated, or activated first. The peroxide is sufficiently nucleophilic to react directly with the ketone, forming the tetrahedral intermediate. When the tetrahedral intermediate collapses, there are two possible migrating groups, the methyl and the aryl, a benzene derivative. The benzene ring can better stabilize the slight positive charge that develops during the migration than the methyl group can, so the aryl group migration has the lower activation energy. The final product is an ester, and hydroxide is generated as a side product. In the next video, you'll see why the migrating group and OO bond are antiperiplanar in the reacting conformation.